Welcome to Lesson 1 of Module 3. This lesson will explore LangChain modules. Today's activities include a review of Module 2 and an introduction to LangChain, its various modules, and the memory component. Recall that in Module 2, we discussed the core dimensions of responsible AI. These dimensions are controllability, privacy and security, safety, fairness, veracity and robustness, explainability, transparency, and governance. Now let's move on to LangChain, a third-party framework not affiliated with AWS. LangChain is designed for building applications with large language models. LangChain is one of the most popular frameworks for developing applications powered by large language models. It provides a modular and flexible architecture, allowing developers to build scalable solutions by combining various components. One of the key strengths of LangChain is its extensive support for third-party integrations, enabling integration with various data sources, APIs, and other external services. This empowers developers to create sophisticated applications that leverage the power of language models while leveraging existing tools and resources. LangChain offers a wide range of use cases, enabling developers to leverage the power of large language models in various applications. Text generation is a fundamental capability, allowing the creation of human-like text for various purposes. Summarization is another valuable use case, where LangChain can condense lengthy documents into concise summaries, making information more accessible and digestible. Conversational chatbots are a popular application, with LangChain providing the tools to build intelligent chatbots that can engage in natural language interactions. Code implementation and understanding is another exciting use case, where LangChain can assist developers in understanding and generating code, facilitating tasks such as code completion, documentation generation, and code explanation. Retrieval Augmented Generation, or RAG, is a powerful technique that combines information retrieval and language generation, enabling the creation of content that is both relevant and coherent. For reasoning agents, LangChain can be used to develop agents capable of performing complex reasoning tasks, such as question answering, decision-making, and problem-solving. There is also so much more. Why should you use LangChain? With LangChain, the focus is on prompting existing LLMs instead of training or fine-tuning. There are existing LLMs that can be adapted using prompts and scripts. This is preferable because training or fine-tuning is usually more expensive and demanding. Furthermore, LangChain is compatible with existing APIs, enabling integration into existing systems and workflows. Additionally, LangChain has standard interfaces for components, facilitating the integration of various components within the framework. This is particularly advantageous given the growing number of models, APIs, services, and other resources available, each potentially having diverse formats and structures. By establishing a standard interface, LangChain simplifies the process of utilizing and combining these diverse components within a unified ecosystem. Furthermore, the standard interface allows for easy switching between providers. This modularity empowers users to explore and leverage different providers' offerings without being constrained by compatibility issues. Overall, LangChain's standard interface promotes a modular and interoperable approach, facilitating the efficient development and deployment of language-based applications by integrating various components from multiple sources. AI applications are becoming increasingly complex, necessitating efficient orchestration of various elements into custom-controlled flows. LangChain facilitates this by enabling the creation of task plans that can loop until the desired goal is achieved. The data can also persist across multiple stages. This approach allows for the inclusion of human decision-making, reviewing, and other interventions. The orchestration capabilities of LangChain empower developers to effectively manage the intricacies of modern AI applications, streamlining the process of integrating and coordinating multiple components to achieve desired outcomes in diverse tasks. Furthermore, LangChain offers observability and evaluation. It has traceability features that allow for observing outputs at all stages. This capability facilitates testing specific portions without running the entire workflow, streamlining the development and debugging processes. LangChain provides tools to measure and achieve desired outcomes, such as latency, performance, and cost optimization. These metrics are crucial for ensuring efficient and cost-effective operation of AI applications. LangChain modules provide a modular and extensible architecture, enabling developers to build and customize AI applications by combining various components. Let's discuss these modules more. Prompt templates are parameterized inputs that serve as predefined recipes for large language models. These templates may include instructions, context, and few-shot examples to guide the model's behavior. The key advantages of prompt templates are that they are model agnostic, allowing them to be reused across different models, and reusable, enabling the creation of standardized prompts for common tasks. The slide provides an example of a prompt template for generating a 3-day itinerary for a trip to a specified city. The template takes the city name as an input parameter and incorporates it into the prompt, demonstrating how templates can be parameterized to handle dynamic inputs. Output parsers are components that parse the output of the large language model into various formats. String output parser converts the output into a string format, JSON output parser into JSON, XML output parser into XML, and Boolean output parser into a Boolean value. These parsers are useful when the output of the LLM needs to adhere to specific formats for downstream tasks or integrations. By providing a range of output parsing options, the system allows for flexibility in handling the LLM's output and facilitating seamless integration with other systems or processes that may require data in particular formats. Chains enable building complex applications by chaining modules together. This allows for a sequence of calls to the large language model, tools, or other components. Chaining simplifies intricate tasks that require multiple steps and components by breaking them down into a series of modular operations. One key advantage of chains is the ability to easily switch out individual components without disrupting the entire workflow. This modular approach provides flexibility and maintainability. The LangChain library offers a convenient way to define and execute chains using its expression language, LCEL. LCEL is designed to be user-friendly and straightforward, making it easier to leverage the power of chains for building sophisticated applications that integrate large language models and other components. LangChain Expression Language, LCEL, is a powerful tool that simplifies the process of composing chains. With LCEL, you can easily combine different components and modules into a cohesive workflow. LCEL offers several benefits that enhance the development experience. It provides robust streaming support, enabling efficient data processing and real-time analysis. Additionally, LCEL supports parallel execution, allowing you to leverage multiple computational resources simultaneously, thereby accelerating the execution of your chains. Furthermore, LCEL empowers you to configure retried and fallbacks, ensuring that your chains are resilient and can gracefully handle errors or failures. This feature enhances the reliability and robustness of your applications, minimizing downtime and ensuring consistent performance. Another notable aspect of LCEL is its ability to provide access to intermediate steps within a chain. This feature allows you to inspect and analyze the output of individual components, facilitating debugging and enabling a deeper understanding of the chain's behavior. Finally, LCEL enables you to specify input and output schemas for conformity, ensuring that your chains adhere to predefined data structures and formats. This feature promotes consistency and interoperability, making it easier to integrate your chains with other systems and components. The slide introduces a simple LLM chain, which combines a large language model, a prompt template, and an output parser. It defines a prompt template using the prompt template class from the LangChain library with a template string tell me a content_type about topic. Next, it creates a simple LLM chain by piping the prompt template through an LLM and a string output parser. This chain is then invoked with the content type bedtime story and the topic a cat. The output shows the beginning of a bedtime story about a curious black cat named Midnight. This example demonstrates how LangChain allows you to easily compose components like prompt templates, language models, and output parsers into a simple chain for generating text based on specified inputs. The modular nature of LangChain enables you to build and customize these chains for various natural language processing tasks. Multiple chains can be connected together to create complex workflows. The flow can be defined using proper input and output variables. The example illustrates a workflow involving 3 chains: a screenwriter chain that takes a movie title as input and generates a synopsis, a movie critic chain that takes the synopsis and produces a review, and a social media manager chain that takes the review and target demographic as inputs to generate a social media post. This demonstrates how individual chains can be composed into a larger workflow by passing outputs from one chain as inputs to the next, enabling the creation of more intricate processes. By carefully defining the input and output variables, you can orchestrate the flow of data between these interconnected components to achieve the desired functionality. Memory is a crucial component in many applications, enabling the storage and retrieval of information. Let's now discuss memory. Simple prompting is a straightforward approach to interacting with language models or AI systems. It involves providing a direct input or query, and the system responds based on its understanding of the prompt. However, as illustrated in the example, simple prompting can sometimes lead to undesirable or nonsensical responses, particularly when the prompts are ambiguous, lack context, or contradict previously provided information. The key issue highlighted is the system's inability to maintain coherence and consistency across multiple prompts. In the first prompt, the system is introduced to Andy, but in the second prompt, it fails to recall this information. This inconsistency arises due to the limitations of simple prompting, which treats each input independently without effectively retaining and leveraging the context from previous interactions. Therefore, without any component persisting context, the LLM is unaware of prior interactions. This means that LLMs, in their simple form, are stateless, treating each input or prompt independently without retaining or leveraging the context from previous interactions. Input is provided with a prompt, and then a response or output is given. Memory is a crucial component in conversational AI systems and chatbots to overcome this issue. It allows the large language model to maintain and refer to information from past interactions, allowing for persisting context, roles, rules, and other relevant details. This allows the LLM to dynamically store and access information. This capability is particularly important for coherent and consistent multi-turn conversations, where the LLM needs to remember and build upon previous exchanges. Memory features can help the LLM to provide contextually relevant responses and maintain a natural flow in the dialogue. As such, it is commonly employed in the development of chatbots and other conversational applications that require tracking and leveraging contextual information over the course of an interaction. The slide illustrates the workflow of an LLM application that incorporates memory. The input, which could be text or other data, is combined with the retrieved memory to form the prompt. This prompt is then processed by the LLM, generating the response or output. Additionally, the memory can be updated or written to during the interaction, allowing the system to dynamically store and accumulate new information as needed. When prompting with memory, when saying, "Hi, my name is Andy," and then asking, "What is my name?" the LLM can recall from memory the name and respond, "You introduced yourself as Andy." Conversational memory refers to the ability to store and retrieve all interactions and dialogue history, enabling perfect recall of previous exchanges. The slide demonstrates how a conversation buffer memory object can be created and used to save context from user inputs and model outputs. This allows the system to maintain a record of the conversation flow. However, the slide raises a pertinent question. What if the conversation is too long? This concern arises because storing an entire conversation history can become impractical or computationally expensive for extended interactions. This challenge will be addressed in the next lesson. This lesson covered LangChain, a framework for building LLM-powered applications, and a few modules offered by the framework. In the next lesson, you will learn about developing conversational applications. Thank you.